Hello, college biology. This is our next electronegativity video over bonding, and we're going to discuss, we'll start with nonpolar covalent bonds, and we'll see how far we got. In our previous video, where we discussed ionic bonds, we recognized that the bonding is explained by electronegativity based on the electronegativity of the two atoms in the situation. And in an ionic bond, you have an atom with high electronegativity and an atom with low electronegativity. Well, in a nonpolar covalent bond, you have two atoms of very, very similar electronegativity. They can both have high electronegativity or they can both have moderate electronegativity. However, if you have atoms with low electronegativity, they will not form a bond. And that's because both of those atoms are struggling really hard to hold on to their own electrons. If they have a low electronegativity, they don't have the influence to pull electrons from other atoms. So if you have two atoms with low electronegativity, they don't interact. So for nonpolar covalent bonds to occur, they have to be atoms with high electronegativity or moderate electronegativity, and they have to have electronegativity close to each other. So let's look at our example. This is hydrogen. Hydrogen is an atom with moderate electronegativity, and what happens is both of these atoms are going to attempt to pull electrons from other atoms, and they're equal. So what happens is this atom pulls an electron from the other atom, but because they are equally powerful with their electronegativity, this atom is also pulling an electron from the other one. So this electron gets pulled, and it buzzes around this atom in its wild motion, and then it gets pulled back. But at the same time, this original electron was pulled, and then when it gets close, it gets pulled back. And so both of these electrons are evenly being pulled and evenly spending time moving about wildly in this orbital that surrounds both of the atoms. What happens is they end up forming a hybrid cloud of electrons that surrounds both of the atoms and keeps both of the atoms united together, and so that the nuclei can't escape. They're all surrounded by the same electrons. This is a nonpolar covalent bond. You have the equal sharing of valence electrons, which forms a hybrid orbital that surrounds both of the atoms. Those atoms are now bonded together because of this sharing electrons, and it's all because they have equal pull on each other's electrons because they have very close electronegativity. So let's take a look at another covalent bond. This one will be a polar covalent bond. In a polar covalent bond, there is a difference in the electronegativities. We have fluorine, which is a very strong, very high electronegative atom, and then we have hydrogen, which is a moderate electronegative atom. So fluorine is going to take electrons from hydrogen, but unlike in ionic bonds, hydrogen has a moderate pull, so it doesn't let go of them fully. It still can attract electrons, so the electrons from hydrogen are going to go over to fluorine, and they'll buzz around here, and then occasionally they'll get pulled back to the hydrogen, but then they'll get quickly pulled back to the fluorine. So what happens is the electrons are not shared evenly. We have uneven sharing of electrons. And, well, what does that mean? Well, if we have electrons over by the fluorine more often, that means that the fluorine is going to have some of the qualities of those electrons more often, which will be the negative charge. And the hydrogen will have the opposite. It will have fewer electrons more often, so it will have sort of a positive charge. We call these partial charges, and the symbol for a partial charge is this symbol here. This is a partial positive, and this is a partial negative. So in this atom, this side has a region of partial negative because most of the electrons are hanging out over here during most of the time. And over here we have a region of partial positive because fewer electrons are here most of the time. That means that this is a different covalent bond. We do have the sharing of electrons, but we have the uneven sharing of valence electrons to create a hybrid orbital that surrounds both of the atoms, which results in regions of positive charge and negative charge. Now, overall, this atom is neutral because the charges even out. But regions in the atom have partial charges. So let's review. A nonpolar covalent bond occurs between two high electronegative atoms or two moderate electronegative atoms. Both atoms try to take electrons from each other, but neither is strong enough to do so permanently, like in ionic bonds. As one atom takes an electron from the other, the reverse is also true, so they end up constantly trading valence electrons. And the even sharing of valence electrons results in a hybrid orbital which surrounds both atoms. And this hybrid orbital, made from equally sharing valence electrons, is called a nonpolar covalent bond. Polar covalent bonds occur when we have a high electronegative atom that is close to a moderate electronegative atom. Both atoms try to take electrons from each other, but they do not exchange the electrons evenly, which leads to an uneven sharing of the electrons. The region of the hybrid cloud near the highly electronegative atom will have a partial negative charge because it more frequently has a higher concentration of electrons, and the opposite is true. The charges for the overall molecule are neutral, but regions within the molecule will have partial charges. This uneven sharing of electrons forms a hybrid cloud around both atoms and is called a polar covalent bond. Now, I should have said, but I didn't, that the opposite is true for the low electronegative atom. It will have a partial positive charge because more frequently it has a lower concentration of electrons. Anyway, that should be everything for the covalent bonds. We'll discuss hydrogen bonds in a future video. I hope this helps. Struggle well.